OMC team members are farmers, ranchers, growers, fabricators, engineers, and industry professionals. We set ourselves apart with our knowledge not just in manufacturing, but in operating and maintaining nut and tree harvesting equipment. We are passionate about what we do and are dedicated to doing it better than anyone else. Our company builds the most durable, high-performance machines and offers the biggest customer support network in the industry. We do this because we understand that our success is inseparable from yours. OMC, the Shaker Maker.
Okay, you've seen this diagram before. This is the 25 by 25 spacing, 43 feet tall, and an explanation of how we came up with 136,368 square feet per acre. The top side is 5 feet by 4 feet, and the hypotenuse of that triangle is 6.4, and then the side cut is 33 feet long. That gives us 6,864 square feet per side, and the other side cut is the same. So there's 16,390 square feet of outside leaf surface per tree at 8 rows per acre. Now the 8 rows per acre, that's taking 43,560 and squaring it. Take the square root of that, and that gives you a square that is 208 feet by 208 feet. Divide 208 feet by 25 and you come up with 8 rows. So the way to envision this is 8 rows of solid vegetation per acre to give you the 136,000 square feet. And again, the height to row width ratio is 1.7 with 15 feet of open sunlight in the middle. So here's another chart that gives us the outside leaf surface area calculations. The middle spacing is 20 feet. The rows per acre are 10. The total height at a ratio of 1.7 is 34 feet. That gives you 131,523 square feet per acre. And then you can see the 25 by 25 8 rows there. Now, moving down to a 50-foot spacing, that ratio is only actually a 1.2 and a 1-to-1 on the 60-foot. The reason for that is, for the sake of this argument, we decided that we did not want to let a tree get over 60 feet tall for several reasons, but the main reason being that 60 feet is really about as high as you can spray and have really good coverage and effects of your materials you're putting up there. We do a little better than that with some 80-foot tall desirables that are clean at the top. You saw those pictures, and with our Stewarts that are anywhere from 80 to 120 feet tall, but that is achieved with spraying out of one side with a volute at 1.75 miles per hour. Here's young high density harvesting. This is actually OMC's catch frame. This machine, or these two machines, can run autonomously, which means they run by themselves. They grab the tree, they shake it, they pull away from the tree, and they index to the next tree and do the same thing, all at the push of one button. All the operator has to do is sit there, and the only reason they need an operator now is to turn it around at the end of the row and get it lined back up. But I talk to Don Mayo pretty regularly about this, and he seems to think he's made some, he thinks he's made some progress on the turnaround issue. So, high density pros and cons. It's not for everybody. We get that. But here are what some of the potential pros are, because none of it's really proven out at this point in time. Early cash flow, possibly more pounds per acre, definitely more uniform tree height and shape for better spray coverage, and uniform equipment in operations, which should bring your cost down. Smaller spray equipment, that rear sprayer with the radar unit on it was about $50,000. Now I think they're about 58, versus $150,000 diesel air blast sprayer. Lower operating cost, and again, with the GUSS systems that we'll do a little bit of introduction to that today, but you can certainly see them advertised on the Pecan Report. That's a proven technology, but the trees have to be the right size. And the catch frame harvest systems, no limb crew, fewer engines per acre, and more harvest time. And what I mean by more harvest time is, since you're not held captive to ground conditions as far as them being wet with dew or rain or something like that, then you can either get back into the field more quickly after a rain, or increase your operating time in a given day. The way we laid Branchville out was originally not to keep it at 25 by 25. We planted every other row a different variety, and our plan was to get to a 25 by 50 with the variety that was performing the best, and then just cut down the lesser performing variety. Our thought has changed on that, but even if we are unsuccessful at high density, we still have a very viable orchard at a 25 by 50, where we can have the agility to pick the optimum variety, and then with the 50-foot middle, if that's doesn't prove out to be optimum, or one of Patrick's releases comes along, or another release, we can still plant a row of trees in that 50-foot middle and keep going, just like our friends in the peach business that replant their orchards from time to time, or the almond business. The cons, they're pretty obvious. Much higher planting cost. You're going to have to hedge. The best varieties to date are unknown. Also unknown are the long-term effects of hedging. Is that tree going to respond to hedging year after year after year, or is there going to be some unknown negative effect in the future? And probably the biggest con to high-density planting is there is more unknown than proven at this point in time, but we're going to give it a try.